Welcome, I'm Matt Mead, Chief Technology Officer for SPR, and today we're talking about topics related to data, and we'll be pulling in insights from our technology industry survey. In our survey, we asked 400 IT and business professionals an array of questions about their technology organization, and we're going to use these answers to build our technology leadership forecast. So I'm really excited to have Zach Bannor and Kevin Young join me here today in a conversation around data. Thanks for being here, guys.
Thanks for having us, Matt.
So from our survey, we discovered that IT leaders overwhelmingly selected data analytics and business intelligence as the #1 area for a technology organization to allocate resources. And I wanted to start by unpacking this with you both and ask, do you agree that the data analytics and business intelligence is the most important skill listed?
Well, Matt, I understand the importance of data analytics and business intelligence, and I understand why business professionals strive to those goals, and they place these very highly on the survey. However, you cannot forget about how you get these insights, how you get the data for analysis and for business intelligence, and all that comes from data engineering. Data engineering is the foundation upon which you can build a solid analytics platform. Everybody wants to have data-driven solutions and data-driven decisions. However, if your data is faulty, if you're not doing your due diligence during the engineering process and getting the correct data, the data cleansed correctly into your analytics stores, it's impossible to actually draw insights from the data that you have. So while I disagree that data analytics and business intelligence might be the most important, I understand why it is the most sought after and the most highly rated on the survey.
I think that over the course of the last 10 years, we've started to really build out data warehousing and data store technology. And now and most businesses have that developed, and now they're at the point of needing those insights in the boardroom and there with the decision makers. So to me, that it's less surprising that that is the #1 thing, because that is what keeps those people employed.
Is the process of data science iterative?
Of course it is. Models need to be consistently, not necessarily rebuilt, but refactored. You need to monitor your models for accuracy or for overfit. That requires iteration on your models and also on your data engineering processes.
The most simple models are the best models, and simple means you iterate, you create the simplest thing you can, and then you add a little bit more on top of that, a little bit more complex, a little bit more complex. But if you skip those steps and you create something that is overly complex, that is hard to understand, because that's really the secret sauce of what a lot of these businesses are looking for in machine learning is that explainability. How can I explain my model? How do I know what features are the most important in a model? And oftentimes, if you throw the more complex model at it, it turns into a black box. They don't know how to use it, and a lot of times these models aren't perfect when they start. So the explainability helps you in filtering out things that don't matter. So yes, very much so. Iteration's very important in the data science process.
So we started with this overwhelming response in our survey that data analytics and business intelligence was the #1 area where IT leaders were focusing their resources. And I'm just curious, what do you think's behind this overwhelming response?
These are the things that business stakeholders want to bring into the meeting rooms to show off. Look at what we've been able to build, what we've been able to derive from our data. It's not surprising at all that would drive the responses. I think that it's incredibly important, however, for us to reinforce the idea that you can only derive insights that are as good as the data that's going into your models, which is coming back to my point that the foundation of all insights, of all data analysis, is really data engineering. And maybe I'm biased because I'm a data engineer, but to Kevin's point earlier also, the propensity to jump ahead to aspects such as building models or building visualizations prior to actually understanding the data that's required to go into those models and those visualizations to propagate correct, usable insights, I think that is not necessarily a failure on the part of the business, but just an oversight.
I'm curious, Kevin, building on that, we're talking about maybe putting the cart before the horse, trying to jump in and do some of the modeling too early in the process before the data is understood, or something along those lines. Have you ever been involved in any experiences along these lines? Any stories from the trenches that you could share with us?
Yeah, so we actually see that all the time. Oftentimes what happens is we create an initial machine learning model just using data that the business has collected over time. And once we show that off to leadership, what happens is leadership comes back and they say, man, we have all these other great things that we'd like to get put into the model. And then we go back and we say, okay, do you have any historical, have you captured that feature historically? And they say, oh, no, we haven't. It's we tuck it away in an Excel sheet or something like that. And we go, well, we can't include that on a lot of these models that require historical data to run. We need past records of that. So, and also what we see as well is a lot of times once leadership gets a hold of a model and its predictive ability, they're doing things that they don't want to be doing. They might be collecting some survey data or something like that, and they go, hey, let's incorporate this data into the model so the model will tell us that it's useless and we don't have to do it anymore because we don't think it is useful anyway, right? Because they have that bias thrown in there anyway that they don't want to do it. But yeah, we're able to, if they have that data and they have historical records on the time scale that we're running this model, looking back on, we can incorporate that in. But oftentimes, yeah, we do see the cart put before the horse, and they end up going back and start incorporating more features in to their data warehouse, data lake, whatever their data stores are, in order to remediate that.
When we asked IT professionals to rate their data maturity, we found that about 45% rated themselves pretty high for their organization. However, when we specifically look at the leading organizations, they do not rate themselves quite as high in that data maturity model. So does this data surprise you in any way?
Surprisingly, no, it's actually not surprising. I would expect that people who are truly in tune with the state of their data would rate themselves lower. As you get deeper and deeper into knowledge of any subject, you start to realize all the things that are out there that you just don't know. Personally, during my academic studies, I mean, it was extremely elucidating to understand that I understood a speck of the subject material. And you start to think of yourself as being actually somewhat deficient sometimes because of your knowledge of your lack of knowledge. So I would expect that true experts, true people, or people who are truly, again, in tune with the state of their data, the state of their data programs, would seem to think of themselves as being less capable than other people who don't actually have insight into the state of their data affairs.
So talking about maturity and that scale, should organizations be trying to get to that maximum, that highest rung on the maturity scale? Is that the target? Is that where folks should be focused?
I think if we learned anything from big tech from 1995 on, is that if you have great data collection practices, that is very profitable. And what a lot of these companies have done is they have really great data collection processes, really great data engineering processes, and they're able to drive very large profits from that. And businesses and organizations, everyone can benefit from that, even at the organizational level. So if you have great data collection processes, great data storage processes, you can drive better business outcomes much better business outcomes than you could otherwise. And that's just based on what we've seen from a lot of these Silicon Valley companies and a lot of smaller companies.
So both of you talked about the value that a good data platform can provide for an organization. It can be extremely lucrative. We also talked about the fact that it's good to aim high for an organization with respect to their data maturity. I'm curious, is data a journey? Is it this never-ending journey that's iterative and we're going to be doing it forever? Or is a high maturity in data a destination and we can get there and we're sort of done?
I would argue that, like all things in life, your data platform, your data collection, the insights that you derive from your data, it's a journey. no matter how good your data collection, your data platform, your data program as a whole is, can always be a little bit better. You can always iterate again. You can always add additional functionality.
Kevin, what about, I'm assuming a modern data platform that you're speaking of would be cloud-based. And is it something that requires care and feeding, or is it a write once, deploy, and it just works all the time and doesn't need updating?
Oh, of course it needs care and feeding. I like to use the analogy of like a lifestyle, right? We all strive to be as healthy as possible. We all strive to, look our best, act our best. But, there are many aspects to it that, sometimes you're not as healthy as you'd like to be. Sometimes you're not getting up and exercising. So if you're playing the really long game, you're just trying to maximize all these areas as well as you can.
What advice would you give to an organization that's trying to break the data silos and create strong data practices within the organization and to make sure that resources are fully supported?
Take your time, do it right the first time, really evaluate the technologies that you want to use moving forward. Don't just assume that you need certain technologies because they're big names. Different technologies are the right fit for different situations. Do your due diligence. Putting in effort up front, making the right decisions initially leads to much better outcomes later on. Also, I would argue, much less costly refactoring. Measure twice, cut once.